When we have inverse trigonometric functions, sometimes we're going to see composition of a trigonometric function with an inverse trigonometric function. And normally inverse functions, when you compose when you do a composite between a function and its inverse, they just cancel each other out and you get back x, okay? And unfortunately, that's not going to always be the case for us with inverse trigonometric functions because we have to place those restrictions. And so the functions themselves, sine, cosine, tangent, and so on, they're not actually invertible functions. And so not all the properties always hold. So this property here in particular is the one that's not always going to hold. F inverse of x. This normally is equal to x, okay? But it will not hold within trigonometric functions, okay? However, this will always equal x, okay? Always. So that's really nice, okay? Let's go ahead and just see how that comes into play. So right here, I should say always, if x is in the domain of f inverse, okay? So that's the only thing you would need to check here. So here I've got tangent of the arctangent of -5. So that's looking like this, function of an inverse function of x, okay? Now -5, what you need to check is -5 in the domain of the arctangent. And the arctangent has a domain of all real numbers. You can plug anything you want in. If you remember the graph, it looks like this, okay? Where you can plug any number you want in. And so -5 is in the domain of arctangent. So then the tangent and the arctangent will just cancel each other out. And this is equal to -5. Okay, let's look at this part B here. Here it's flipped around. I've got the arc sine of the sine of 5 pi over 3. So this is like this first one, and that's not always equal to x. So we had to do some work. And all we do is we work our way from the inside out. So we start off by doing this inside, what's the sine of 5 pi over 3? So based on our knowledge of the unit circle, we do that. Sine of 5 pi over 3 is -√3 over 2. Okay. And then, now we're doing the arc sine of -√3 over 2. So what we do is we look at where do I have an angle where the sine is -√3 over 2. And there are two places that happens, down here and down here. But the arc sine only gives us a number between -pi over 2 and +pi over 2. So it has to be this angle right here. And you'll notice that this angle, this is in the same location as 5 pi over 3. Okay? And that's no accident. So here I've got that angle, which coterminal with 5 pi over 3 down here is between -pi over 2 and pi over 2 is -pi over 3. Okay, so you can see then that that the inverse outside with the function inside, those don't just cancel out. We have to do a little bit of work. Okay, and finally here we've got cosine inverse of pi. And this looks like this f of f inverse. Now, this is always equal to x, as long as x is in the domain of f inverse. So we look at this and we say I have cosine inverse of pi. Well, cosine inverse has a domain of -1 to 1. Pi is outside of that, which means there's nothing we can do because this right here is undefined, which means the whole thing is undefined. Undefined or does not exist.